So I want to talk about absolute location using latitude and longitude. And in the first portion of the course, we're just going to use latitude and longitude mostly by whole degrees. And then as we get into looking at topographic maps, we may start using degrees, minutes, and seconds. And hopefully I can give you some idea today about what that looks like if it's been a few years since you've talked about latitude and longitude. It's a grid system that's used to help identify location on a map. There are several grid systems. If you work for the search and rescue, they use a system called UTM, but we're going to use latitude and longitude in this class. And latitude and longitude are based on mathematical idea of the distance in a circle, or the degrees in a circle. So if I look at a circle, so there's 360 degrees in a circle, meaning I can cut this into angles, and the distance between the zero, if I travel along the edge of this circle, to 30 degrees is a length of distance. So when we're talking about traveling so many degrees of latitude and longitude, we're actually talking about a distance traveled on the surface of the Earth. And you can see that if I'm looking at a small circle, that distance from 0 to 30 is smaller than the distance on a large circle. So the distance traveled in degrees along the Earth's surface is based on how big the Earth is. So when we look at the grid system used to locate places using absolute location, there are two systems of lines. One is the latitude lines, or the parallels. The second is the longitude lines, or the meridians. And you can see in this image on the left, the latitude lines, or the parallels, run in concentric circles, meaning the circles get smaller and smaller. They start at the equator, go to the poles. The meridians run from the North Pole to the South Pole, and they run from 0 to 360 degrees. So let's look at the parallels first. So we have to start somewhere, and so the first primary line of latitude is the equator. It's right here at 0 degrees latitude, so that's the starting point. And it divides the Earth into the northern hemisphere and the southern hemisphere. And there are 90 degrees in the northern hemisphere and 90 degrees in the southern hemisphere. And so if I am looking at that doesn't look very good. Let's move that to the front here. There. Oh, nope. That's okay. Hold on a second. There we go. So here we are at 0 degrees latitude. The North Pole is at 90 degrees latitude. And if I were able to do a cutaway and find fossil Oregon on the surface of the Earth, if I traveled along the Earth's surface from the equator up to fossil, I would be traveling about 45 degrees of latitude. Now, a degree of latitude is about traveling 69.2 miles. So basically, from the equator to fossil Oregon, if I could travel in a straight line as the crow flies, I would be traveling about 3,100 miles across the Earth's surface. Lines of longitude, then, if you add up all of the lines of longitude, there's 360 degrees of longitude. But it's much more convenient to think about eastern longitude lines and western longitude lines. So there's 180 degrees of longitude to the east of the starting point, which is the prime meridian, and there's 180 degrees west of the starting point, which is the prime meridian. And you'll see that the lines of longitude converge. So at the equator, this little arrow here, one line of longitude is also about 69.2 miles. But those lines get closer and closer together as you move toward the pole. So at about 45 degrees latitude, these two lines of longitude are much closer, or almost half as far apart. So we're thinking about distance. 69 miles is a pretty long distance if I want to try to pinpoint location. And so we have to divide degrees into smaller angles, and those are called minutes. So 1 degree can be divided into 60 smaller sections, or 60 minutes. And so 1 minute of latitude is about a mile. So now I could find something if I locate it by minutes of latitude and longitude. I can get a lot closer. But you have to think about this a little bit like you would a clock. We don't talk about 12 o'clock and 61 minutes. That 60 minutes would make that 1 o'clock. And so we have to think about that also when we're talking about degrees of latitude and longitude. So if I have a location that is 10 degrees 58 minutes north and I travel 2 more minutes, I'm going to add those 2 minutes to my 58 minutes, which means now I have traveled 60 minutes, and that minute is another whole degree. So my new location would be 11 minutes north. Same if I go east and west. If I travel if I'm at 58 minutes east and I travel 2 more minutes east, then I'm at a whole nother degree. And to make it even more accurate, each minute can be divided into 60 smaller sections, or 60 seconds. Again, like a clock, 1 hour is divided into 60 minutes, and 60 minutes can be divided into seconds. And each second of latitude is about 100 feet. So we're getting much more accurate with our locations of latitude and longitude. And the same idea applies when you add seconds. So if I'm located somewhere at 10 degrees, 59 minutes, 58 seconds, and I travel 2 more seconds north, remember seconds is a distance, so I've traveled 200 feet north, that actually means I'm now at 60 seconds north, and 60 seconds is actually another minute. So I'm going to add that over here, and 60 minutes is actually another degree, so my new location would be 11 degrees north. We won't have to do too much of that in this course. So one thing that makes it a little easier to locate places on a map is to not use the spherical map, but to kind of spread it out on a flat two-dimensional surface. And so if you look at the Earth in this perspective, you have the prime meridian at 0 degrees longitude, and so the eastern hemisphere is shown with positive numbers up to 180, and the western hemisphere can be shown with negative numbers from this would be 30 degrees west, 60 degrees, 90 degrees, 120 degrees, 150 degrees, and 180 degrees western hemisphere. The equator is at 0 degrees latitude, and again, latitude only goes to 90 degrees north or 90 degrees south. So what I want you to be able to do by the end of the course is to locate places on a grid using latitude and longitude. So you're always going to put latitude first. If you put longitude first and latitude second, that would be an incorrect answer because it would be an incorrect location. So if I have a grid and I don't know what these lines represent, I know that there are only 90 degrees in the northern hemisphere. So if I count these sections, I've got 1, 2, 3 sections. I divide 90 by 3, and so each of these has to be 30 degrees. The same with the longitude lines. I've got 1, 2, 3, 4, 5, 6 lines of longitude. I have 180 degrees of longitude, so if I divide 180 by 6, each of these grid sections is 30 degrees. So now all I have to do is locate first, am I in the southern hemisphere? I'm going to look at this arrow here on the right. So I am in the southern hemisphere for latitude, and I'm one line down, so that's 30 degrees south, and I'm just one section over, which is 30 degrees east. And there's two ways you can record that. And because some people have trouble making the degree symbol, I'm going to let you use the asterisk to indicate degree. If you were to turn in an answer like this, that does not indicate location. That is just a pair of numbers. So you have to use the degree symbol or the asterisk. Or you can write out degrees, but that's pretty painful. Okay, so the correct way to record this would be minus 30 degrees, that's the latitude, comma 30 degrees longitude. Or you can write 30 degrees south, comma 30 degrees east. You'll notice that this 30 is a positive number, and so I don't have to put a symbol for a positive number. I only have to indicate a negative number. So either of these would be acceptable. If I look at this arrow, it's in the northern hemisphere for latitude, so that's a positive number, and it's in the western hemisphere for longitude, so that's a negative number. Again, 30 degrees is my latitude, so here's 30 degree mark. There's no sign because it's positive. And then 30, 60, 90, 120, 150, I did that wrong. 150 degrees. So this is 30 degrees north, negative 150 degrees, or you can write 30 degrees north, 150 degrees west. I would accept either of those.